Hello everyone. In last class we started with this chemistry Edxcel foundation paper and we did till question number 7. Now we are going to start with question number 8. So this is part 2. If you haven't watched part 1, please check that on my YouTube channel. And also if you want to take free classes, I take free GCSE math and science classes. In science, all of them: physics, chemistry, biology. You can contact me on WhatsApp. This is my number 919205948909. Um, or you can text me. You can comment. You can comment me. I can give you the link there. So I take classes on Teams. If you want, you can join there. Okay. It's live classes. We can interact. We can talk about doubts and all. Okay, let's get started. So barium hydroxide react with dilute hydrochloric acid to form barium chloride solution. Complete balanced equation by adding numbers in front of HCl. So balance means both side number of atoms should be equal, reactant side and product side. So as you can see, barium reactant side there is 1. So it is balanced, and then you can see oxygen is 2 and this side oxygen is 2, right? So it is balanced. Hydrogen is 2, this side hydrogen is 4. 2 times 2 is 4, right? So here 4 and 2, hydrogen is not balanced. Actually hydrogen is 3 here, 1 and 2, and this side we have 4, so this side we have 3. So what we can do, if I put 2 here, so hydrogen this side will become, this is 2, right? 2 hydrogen here and 2 here, this will become 4, right? And now we can even see chlorine is 2 2, so we just need to put 2 here, and now our equation is balanced. We can check both side. It is barium, hydrogen, oxygen, chlorine, everything is same. Balance means number of atoms for each element should be equal, both side. Reactant side, this is reactant, and right side of this arrow, these are products, so they should be same. Like here barium is 1 1, like that. So if we put 2 here, both side we have same number of hydrogen and chlorine, so it is balanced. State what you would see during the reaction. So this is a reaction where a solid base, this is a base, barium hydroxide, is reacting with acid which is in aqueous form, right? This is solid, S means solid, this is aqueous, and it is forming a salt. This is a salt, barium chloride, and and there is water. So basically this is a type of neutralization reaction. This is called neutralization reaction. Neutralization reaction. Why? Because base is reacting with acid and making salt and water. This is called neutralization. So the white solid barium hydroxide would disappear, or it will dissolve as it react to form a clear colorless solution of barium chloride. Okay, so this is we will see that barium chloride is formed. You just need to explain this. So this is a neutralization reaction, and this is what you need to write. Uh, so okay, next is, yeah, this. A student investigate how the pH of the mixture changed as barium hydroxide was added to dilute hydrochloric acid. These are the steps. The student used this method. Step 1 is he measured 50 centimeter cube of dilute hydrochloric acid into beaker using a measuring cylinder. Step 2 is use a glass rod to place a drop of acid onto a piece of universal indicator paper and record pH. Then add one spatula measure of barium hydroxide to acid and stir the glass rod. Use glass rod to place drop of mixture onto a piece of universal indicator paper and record pH again. And then repeat step 3 and 4, these two steps. No further change in pH. There is no further change in the pH. Um, so basically, what it is saying is, because this reaction is neutralization reaction, right? So it is neutralizing and we know neutral pH is 7, right? So now based on this, we have some questions here. Let's see these questions. So question 1 is, name a piece of equipment that could be used to measure the pH of a substance more accurately than universal indicator paper. So we can use pH meter or pH probe attached to data longer. It is most common piece of equipment used for this purpose. So pH meter, 1 mark. So we just write pH meter. Why we use this pH meter? Because unlike universal indicator paper, which relies on person's subjective interpretation of color change, pH meter provide precise digital reading. For example, if it is 3.2, 3.2 is like acidic. If we know pH range from 1 to 14, right? It gives us digital numbers. So explain why in step 3 the mixture was stirred after adding barium hydroxide. So why we stir? To ensure the barium hydroxide reacted completely with the acid, okay, with hydrochloric acid through the entire solution, because to ensure that mixture is uniform, okay, to get uniform mixture. And it also, when we stir it, it also allow the neutralization reaction to reach completion before pH is measured, leading to more accurate result. So so that, because it is a neutralization reaction, right? So just to get accurate result, you can write to get accurate results, and um, to get a uniform mixture. This is also called homogeneous. Homogeneous means when something is uniformly mixed, okay, homogeneous mixture. Let's go to question number 3. Figure 13 shows the student's result. This is showing number of spatula measures of barium hydroxide, and this is showing pH of mixture. So when no barium hydroxide was added, pH was 1. And as we are increasing the number of spatulas added of barium hydroxide, pH is increasing, right? So what is the question here? Okay, first we have to plot the graph. So let's plot it. Here we have number of spatula, on y-axis we have pH of mixture, and so for till as 0, 1, 2, 3, and pH is 1, 1, 1. So 0, 1, 2, 3 will start. 0 it is 1, 1 it is 1, 2, 1, 3, 1. Right? When number of spatulas are 1, 2, 3, the pH is 1, 1, 1. Till 0 to, you can see 0 to 3, it's 1, 1, 1. So that's what I did. At 4, when 4 number of spatula is 3. So when this is 4, this is 3. So 4 and 3. Okay. And 5, um, for 5 it is 8, 6, 12. 5, 8. So 5 and 8 is this. 6 is, at 6 it is 12. 6 and 12, right? This, you can see this is 6 and this is 12. And then for 7 and 8 it is 13. So 7 and 8, 13. 7, 8, 7 and 8, 13. So this is how the graph is looking like. Use the graph to find the pH of mixture when 4.5 spatula measures of barium hydroxide are added. So if I just join this graph, the graph is going to go, first it is like straight line, horizontal line. Then from here, if I just join it like this, it's kind of straight line from here to here, then it is going like this, okay. So for 4.5 is this is 4.5. If I just go up like this, you need to use ruler, okay. It's not, I must draw it. I don't know why I'm not able to draw a straight line, but maybe I should go like this. 4.5, you can see this is 6, right? So the pH of mixture when 4.5 spatula, because it says spatula, so you have to check here x-axis, it is talking about spatula. And for 4.5 spatula, the barium oxide is 6. I mean the pH of mixture is 6, okay. Now we can go to next question. So next question is, this figure is showing hazard a symbol on the container of barium hydroxide. What is the meaning of this hazard symbol? Why it is used? This is because it is corrosive in nature. Okay, like it means it shows liquid being poured onto both surface and a hand. It can cause damage to both, and this is the standard international symbol for corrosive substance. Okay, if there is hand and surface. The barium hydroxide was measured in spatula state. One way that measure of barium hydroxide could be improved. Okay, so like in above experiment, they used spatula, right? We have to give some other way which can improve the measurement. We can use digital balance or scale, right? Which give us exact mass. Okay, exact mass. So, or we can use measuring cylinder. It says one way, so you can write either one of them. Let's try this question. Question number 9, which says sodium carbonate. This is the formula for sodium carbonate, and it contains these two ions. Atomic number of sodium is 11. What is the electronic configuration of Na plus ion? So if there is a charge, it become ion. It is not atom anymore. Okay. So sodium, this 11 is the atomic number of sodium. When it is just Na, there is no sign. 11. So how electrons are distributed? This is called arrangement of electrons in different shells are called electronic configuration. So in first shell, only two electrons. First shell can only occupy maximum two electron, and second shell can maximum occupy 11 electron. So 2 and 8, sorry, not 11. Second shell can occupy 8 electrons. So 2 plus 8 is total 11, and there is 2 plus 8 is 10, sorry. uh, and there is one more left because it's 11. So first shell can occupy maximum 2, second shell can occupy maximum 8, which is 10, 1. Now they add up to 11, right? But it says sodium plus ion. Plus means what? How this plus charge comes? It means that the atom loses one electron. When an atom loses electron, because electron is negatively charged particle, so the atom get a positive charge because number of electrons are equal to number of protons. Sodium has 11 electron and 11 proton, but now, so as soon as sodium loses one electron, now it has 10 electron and 11 protons. So positive charge is more. That's why we get positive charge. So when atom loses electron, it become positively charged ion. So if it loses one electron, this one we can just erase it. Now what is the correct answer? 2 comma 8, because it has loses um, the atom loses one electron from its outer shell to achieve stable full outer shell. Okay, so the answer is this. Next is, explain why sodium carbonate cannot conduct electricity but a solution of sodium carbonate can. So solution can, but solid cannot. So in solid state, ions are fixed, okay, in the lattice structure. So let me just erase this. So in solid states, ions are fixed in their lattice, okay. So in solid, ions are fixed in their lattice structure by strong electrostatic forces of attraction between particles, and because the ions are not free to move, okay, they are not free to move, um, and they cannot carry electrical charge, and we know as charges move they generate electricity, right, electric current. But in solution, so in solution or in aqueous form, when it is dissolved in water, the lattice structure break down, okay, and ions become free, and as they become free to move throughout the liquid, and they, as the ions move, they carry current, electric current, which that's why they conduct electricity. Okay, that's the solution. And to, if you want to watch, um, like if you want me to make more videos, You can comment and I can just make rest of the questions, or you can join live like other students are joining live on Teams. Just contact or comment. Thank you. Bye.